Good morning, this is Mrs. Coleman, and this is a small lesson today about negative and zero exponents, and there will be some other things in it as well as we proceed through some examples. So in general, when we have negative exponents, typically we're not allowed to leave answers like that, and I know we've been doing that on our most recent papers, and that's okay because we were working and focusing on some other rules. So today we're going to focus on the negative exponent rule and the zero exponent rule. So in general, if you have a negative exponent, you can write this as a fraction, and you're going to move whatever's in the top as a numerator down to the denominator position, and you're going to change that exponent to a positive. Here's an example of that. We have 4 to the negative second power. We can write that as 4 to the negative second over 1. Flip the fraction to have 1 over 4 to the second. And the ones that we're going to work with today contain all numbers, so we're going to take them a step further and go ahead and multiply them out. So 4 to the second means 4 times 4, and 4 times 4 is 16. So we can just leave it as 1 over 16. And we're going to look at a lot more examples. When you have a zero exponent, if we're using a variable such as x, and as long as x is not 0, then anything to the 0 power is just simply equal to 1. So if we get a crazy decimal here, 4.275 to the 0 power, that's just going to equal 1. So this is an example sheet which will be very similar to the worksheet that I ask you to do for your assignment. So question number 1a says 10 to the negative 10 power. So what we can do is we can write that as a fraction by putting it over 1. And because that exponent is negative, we can go ahead and flip it. So I can write this as 1 over 10 to the 10th power. Now, for our purposes, it's okay to leave it like that because that exponent is rather large. But for some of them, we're going to carry them out just a little further. So 1 over 10 to the 10th power is fine, but I want you to understand what this means. 1 over 10 to the 10th power. 10 to the 10th power is a 1 followed by 10 zeros. Okay, so it looked like that. Also, too, you could write it as a decimal if you wanted to. So if you divided this out on a calculator, 1 divided by 10 billion, you would end up with this. Okay? So what happens here, how we had a 1 followed by 10 zeros, when we divide it this way, we have a decimal point followed by 1 less than 10, which is 9 zeros, followed by the 1. Okay, so I'll let you use your discretion on that. I'll accept this answer if you want. Now, some of them know the numbers that are smaller. I want you to work on trying to carry those out if you can. All right, 2a is a fraction going to the negative 2 power. So since it's already in fractional form, everything, the 3 and the 4, both go to the negative 2 power. So what we're going to simply do is just flip the 3 and the 4. So we're going to make it 4 over 3, and we're going to have that to the second power. Now, because these numbers are relatively small, I want you to go ahead and carry this further. So 4/3 to the second power means I need to have 2 of these to multiply together. So 4/3 times 4/3. So when we multiply fractions straight across the top, straight across the bottom, we get 16 over 9, and we can just leave it like that. My next example, 3a, I have 44 to the 0 power. Anything to the 0 power is just equal to 1, and that's it. Number 4a, we've got negative 8 to the second power, which is negative 8 times negative 8. 8 times 8 is 64. And a negative times a negative is a positive. So that's just going to simply be positive 64. My next example, 2/3 to the 3rd power means I need to have 3 sets of 2/3 that are going to be multiplied together. So going straight across the top, we have 2 times 2 is 4 times 2 is 8. And 3 times 3 is 9 times 3 is 27. And we'll leave our answer just like that. Our next example, 0.08 to the second power means I have 0.08 times 0.08. We know 8 times 8 is 64 from an earlier problem. But when we multiply decimals, we have to have 4 decimal places in our answer. And so far, I only have 2 digits. So in front of that 64, I'm going to put 2 zeros. And in front of that first 0, I'm going to put a decimal point. I have 1, 2, 3, 4 decimal places in my 2 numbers that are being multiplied. I have 1, 2, 3, 4 decimal places in my answer. Okay, let's slide up here to my next set of examples. My 1b example, I have 0.02 to the 0 power, and again, anything to that 0 power is just an answer of 1, and that's it, and you just move on to the next problem. 2b, 1 to the negative 94th power, I'll put that over 1. We're going to flip that fraction, and when we bring that to the bottom, we're going to change that negative exponent to a positive exponent. Fortunately, though, 1 is pretty easy to work with. No matter how many times or how many 1s we multiply together, we get an answer of a 1. So no, we don't have to write out 94 1s to multiply together. So I end up with 1 over 1, which is equal to 1. My next example, negative 2/3 to the second power. I need a negative 2/3 times a negative 2/3. So multiplying straight across the top, straight across the bottom, we get 4 over 9. And that negative times a negative is going to be a positive. My next example, 0.8 squared. Similar to what we saw already, we need a 0.8 times a 0.8. So 0.8 times 0.8 is 64. When I multiply those 8s together, I need 2 decimal places in my answer. Fortunately, I have 2 digits there, so I'm just going to put that decimal point right in front of that 6. Number 5b, we have 1,000 to the negative 3rd power. So the first thing I'm going to do is put that over 1. I'm going to flip it and make that exponent positive. And you can stop right there if you want to. If you want to take it a little bit further, then you would have 1 over 1,000 times 1 over 1,000 times 1 over 1,000. And you would end up with 1 over 1 billion. You have 9 zeros. Similar to our first problem that we had. Okay, and you could also write that as a decimal if you wanted to. Okay, so after that decimal point, I'll put 8 zeros and then the 1. Okay, but again, since the numbers get really big, you can just leave it like that if you want to. And my very last example, maybe one of the most challenging. We have a decimal taken to a negative 2 power. So simply put, I could do what I've done on the other problems. Put that over 1. Let's flip it. Oops, I didn't leave much room for my negative sign there. Sorry about that. And when I do that, I get my 2 to become a positive. So let's keep it going and see what we can do with this. So when I take negative 0.1 times negative 0.1, let me show you what that looks like. I get 1 over negative 0.1 times negative 0.1 is positive 0.01. And the really weird thing, if you take a calculator and divide that, 1 divided by 0.01, you're going to end up with 100. So let me just show you one other way you can think about this. this is representing negative 1/10. So we could change this to a fraction if we wanted to. So we could represent this as negative 1/10 to the negative 2 power. We have that fraction form already, so that negative exponent is telling me to flip it. So negative 1/10, when I flip it, becomes negative 10 over 1. And when I do that, that's going to change to a positive 2. And so now all I have, sorry, my paper keeps slipping, negative 10 times negative 10. And negative 10 times negative 10 is positive 100. Okay, so you'll have 2 pages of these to try. Use a calculator if you have to. And by all means, if you have any questions at all, please let me know. Thank you and have a great day.